Hi, my name is Thomas Kim. In this session of video, I'm going to talk about the function pointer. In fact, I was trying to explain callable object in C++, but without explaining function pointer, I cannot actually explain callable object in C++. For more information about the C++ programming technique, please visit this website. I will put the link down below in comment section. Okay, let's get started. I create a simple solution called I will say it function pointer app, and it will be function pointer solution. Okay, I accept all defaults. In computer, everything, whatever you see in your computer monitor has address. Address. And function also has function address. So I will create a function, for example, sum int a, int b. If you are C or C++ programmer, you already know what function is. This sum function simply add two numbers, then returns. Now I create another function called pro. Pro means a product. So I created two functions. We call these functions, okay, I will add studio header file here. Okay, save them. Here I will call them like this: std cout sum 1 2 std, and there. This is what we do most of the time as C or C++ programmer. Okay, so the result 3 is displayed. Now, sometimes we want to pass function as argument or parameter to another function. So I will create another function. Now I created a function named like a call function, and this function calls another function, takes another function as argument. Now let's define this function, call function. Call function actually has three arguments. This is one argument. This is function pointer. It will get function as parameter or argument, and another two argument, integer argument ab. Then it will return pFunc a b. Please watch it carefully. P is parameter here. It is, in this case, this is parameter, P parameter, and A, B. So this call func takes the three parameter and calls that one of the parameter, the first pFunc is function pointer. Now let's see how to use this. We can use like this. pFunc, for example, sum 1 2 SDD, and there. So no, we have to put this. So call func is a function. We send sum this function as a parameter, and we can say another one. call func sum pro 2 3 std and there. Now we run it. Control F5. See, 3 is 1 plus 2. Sum is called, sum function is called, and the result is 3. And in case of this function, call func pro is called 2 times 3. This function is called from call func is called here. Then pro is passed like this function argument, function pointer pFunc 2 to A, 3 to B. Then this function is called. Pro is actually called this way by indirectly. Function pro is called indirectly. This is function pointer. This is function pointer argument. This is function pointer. This is function pointer. Function name actually is address of this function. Now to understand once again, let's try another one. For example, we are creating another function double called dbl func. If this function gets double pFunc, please note that I use star here because this is function pointer and it gets double, then double arg like this. We are creating another function. It returns pFunc again. This is function pointer, then arg like this. Now I will include here cmath function, cmath header file here. Then I can call std cout, or I would std cout, call dbl func, then sign. I would say sign like this. Okay, this is pi division by 2. It is like a half over pi. Okay, so I can run like this, like 1. I will put in there. So we can say in double pi is ATN, arctangent 1 is 1/4 of times like 4. Let's display pi std cout pi std, and there if we run it, okay, this is pi. So we can say half pi. So we can, this way we can call math functions. Not only this, we can call other functions as well. For example, cos pi over so we are calling cosine like this, f5, no, f5. We can get this is approximately to 0, right? So this way we can call functions, But here you should note that this function, call function, returns double. It takes a function that returns double and takes one double. This is a function that that returns double and also take an argument of type double. In this case, this is a function pointer that returns integer and takes two integer as parameter. So these are called function signature. Also, we can call like this. For example, int p int ptr or p int fun int. This is declaration. This is declaration and definition of pint fun of a function pointer that can point to a function that's its return value type is of integer int and takes two per integer int parameters. This pint fun is pointer variable, function pointer variable, so we can say pint fun sum. So we define the sum here. It returns int and takes two integer variable, integer parameter. So it returns int, takes two integer variable. This is function pointer. It gets address of a sum. Then we can call int fun like this. std cout. Now we can run this. Let's see the last line. So this is 7. Now we can assign another function, pint. It's just function pointer variable. So we can put pro. Then here, this is addition. This is multiplication. I will say like this. Now let's run it. Concentrate on this line. Voila. 3 times 4 makes 12. So this is function pointer variable. This is variable. And we want to make it type. It would be this looks very ugly. So for example, we can do like this, type def int. I usually do like this, intz. In this case, intz is variable. Intz is a variable of type integer like this. But we can change it. I will set it like intgt, for example. Then it is just variable like this, intz t a equals 5 like this. It is variable, but we can change it into type. How? We can do this, type def. From now on, intg becomes type. So we can say intg a. See? It is declaring integer. Declaring a is integer in this case. In the same manner, this is variable, function pointer variable. So in the same manner, we can say, okay, I will I'll do this. So int, I can create another one, declare another one, int func ptr. I'm declaring a variable, function pointer variable. This is function pointer variable. Variable means we can assign something else. This is pointer function variable. Now we can turn it to type def. Now it becomes type. Okay. So after this, we can define like this: int func ptr pt1 fpt like this. Then sum. It looks much cleaner, right? Then fpt 3 times 3. We can do like this, right? So this was originally, if we don't have this is function pointer variable, but type def. This is also called the syntactic sugar. Syntactic sugar, sugar, syntactic sugar. It is called the syntactic sugar. So this becomes pointer function. This becomes pointer function type. So instead of doing this, it looks very ugly. In this case, we can say like this: type def int int func ptr int. It looks very ugly. Then we can say here, no, I will create another one, the same one but a different way, just for your reference. Easy. I will say like this: int func ptr. We can now do this like this. Then these two functions are actually identical, because this defines function pointer, and this is a function pointer type. This is function point type. This is function. This is argument. This is argument. So these are actually identical. These two are. So this way we can define function pointer. This is function pointer, and if we put type def, then this becomes function pointer type. I hope you understand. For more about the C++ feature, please visit this website. Thank you for watching.